Welcome back to another tutorial video. In this video we're going to add some obstacles for our bunny to jump over. There'll be some cacti that are going to come scrolling across the screen there. So first off, what we're going to do is we need to create some more grass tiles here so that our cacti have something to stand on. And just to make things a little cleaner in our project, what I'm going to do is I'm going to create a empty game object, and we're going to just call this ground, and we'll copy our two grass prefab instances into there. And if we select both of those, we can drag them across and position them over there. And now we need to make a bunch more copies and place them all the way along here. So what we can actually do to make things a bit easier, we could from our sprites folder, from our prefabs rather, our grass prefab here, we could drag another one into our ground object if we want, and go on like that. Put it actually into the ground object, or we can use the duplicate function. So what we can do is we could grab all three, right click on that and go duplicate, and then that will create us some duplicates, and we can keep going. Now, to get these things to align very nicely to each other, it's kind of hard to line them up, but if you press the V key and hover near one of the vertices, you get a vertex snap when you drag, and that will click things nicely there. So you select the object, press V, and click and drag it, and it will snap based on the vertex. So we'll just grab those and snap them all across, get them all nicely positioned, and then we'll grab the whole lot and duplicate them again, grab the whole lot, and then we can hover over this corner, press V and click it, drags, and there's some fireworks going off in the background there in case you're wondering what the loud bangs are. I'll duplicate that and hover over there for the V and position there, and then we can select the whole lot and kind of just position it so we have a little bit on the screen and a little bit off the other side of the screen, and that's important for later on when we make the actual ground scroll as the bunny's running, which we'll do in a future video. So now that we've got all our grass tiles set up, we can just close down that part of the hierarchy there so we can see and just hide away all the ground elements there. And now we can get going with creating our cactus, our objects. So what we're going to do is go to our sprites folder, and then from our sprites we're going to grab the cactus and drag it into our project. So a little cactus sprite, and then we can drag that into our scene, and we'll just plonk it there for the moment, and we are going to rename it to cactus. Okay, now we want this cactus to move along from the right to the left. So what we can do is we can add a new script. We're going to call this move left. And then we can open that up in our editor. And here is our empty class that Unity creates for us. So what we're going to do is we want to basically every frame update the position of the cactus, move it a bit left. So the first thing we're going to do is we're going to expose a public variable called of type float. We're going to call that speed, and we're going to set it to something like 10. And because it's public, that will allow us to tweak it in the inspector in the Unity, so it's easier to tweak our settings as we come up with one we like. And then in the update method, what we're going to do is we're going to take transform, which is a variable that's set up for the mono behavior, and it's basically the position of the object or the game object itself, pretty much. And we're going to take its position, so the transform's the game object, or part of as a component of the game object, and we're going to take the position of that, and we're going to add to the current position a vector 3.left, so a vector that's pointing to the left. And we're going to multiply that by the speed, because we want to move left at our speed. And we're going to finally multiply that by time dot delta time. If I can spell that correctly. All sorts of typos today. Alright, so what this is doing for us is that we're taking the current transform, the current position of the cactus, and we're going to add to it a left vector, which is normally, it just has a value of 1 pointing in the left direction. We're going to multiply that by speed, so it would be a vector left at a magnitude of 10, and then we're going to multiply that by delta time. So delta time is, I think we've mentioned before, is pretty much the amount of time that it took to complete the last frame in seconds. So it'll be a fractional part of a second. And so by multiplying our left vector multiplied by the speed multiplied by the delta frame, what we're effectively saying is that we want to move left at 10 units per second, because we're only going to multiply by the amount of time that has gone past since the last update. So that's important for a couple of things. If the engine has a hiccup or gets slow or something like that, and we drop a frame, for instance, our object will still move at a constant amount left in terms of time. If we were just moving, say, 1 unit every frame, and then we dropped a frame, it would kind of slow down. Also, if we play on different devices that have different frame rates or different playback speeds, this ensures that the object will always move at a certain amount of units per second, regardless of how many frames, what the frame rate of the actual playback device is. So if we save that and switch back to our environment and to Unity IDE, and we've got a speed 10 at the moment there, if we press play, we should see the cactus go whizzing past. Alright, so first thing we need to do is have a look at the cactus's speed. That's a little fast, so let's try set it to something like 5 for the moment. Have a look. That seems a little bit more reasonable. Alright, so we'll leave it at that for the moment. Now the thing you would have noticed when we run that is that the cactus just scrolls on past and doesn't interact with our bunny at all. And that is because we don't have any colliders on the cactus. So what we can do is we go to add component, physics 2D, and we're going to add a box collider. And that will add a square box around there. And if we run that now, we should see our bunny getting pushed off the screen, which is great. But now if we actually zoom in on this box collider and we have a look here, we can see that the collider itself is just a big square box. And that means if the bunny interacts with any part of the square box, it will be considered a hit. Even, for instance, if the player manages just to hit this corner or come down there or miraculously hit this corner over here, that would be considered a hit. And so our hitbox there, or our collider, is probably a little too coarse and a little unfair to the player. So what we can do is we can actually reposition this and add some additional colliders or to cover the shape that we want to cover. So if we hit this edit collider button here, we can now drag our collider shape around to something that's a little bit more realistic, something like that, and we might drag this one a little across there. And of course now these bits will not be collided with at all. So what we can do is we can step out of edit and we can add ourselves another box collider, and we can edit that one, and we can position that to something like over there. This bottom portion probably doesn't matter because there's no real way for the character to get under there. And then lastly, we'll add another box collider and edit that one to handle this side of things. So if we actually look at our box, add in our physics 2D, you can actually add more sophisticated colliders, like a circle collider, or in our case a polygon collider, which would actually allow you to drag and edit quite an accurate shape around there. In our case, I don't mind that our colliders are slightly, our hit detection is slightly rough, because that makes the game slightly trickier. And also doing a collision detection for a box or 3 boxes is would be generally faster than doing a collision detection on something with more complicated, like a circle or a polygon. Having said that, if you had a game where you really need accurate collision detection, you'd probably want to use something like a polygon collider. All right. So with that done, if we now run our game, as we saw before, our bunny gets hit and pushed away. What we really want is actually for that to kill the bunny, or for at least the game to reset if we crash into the cactus. And so what we're going to do is we're going to go and edit our bunny controller script, and we're going to add a new method on here. And what we're going to add is a method called on collision enter 2D, because we're using the 2D physics engine. And we're using a collision 2D called assuming I spelled that all correct, double check that. Yes, so this method will be called when something collides with our bunny, and then the collision object will tell us a bit about what it collided with. And so what we're going to do is we're going to say application dot load level application dot loaded. All right. So the application object is a global class that provides access to a whole bunch of application-specific functionality, and one of those is to load level, and load level actually tells it to load a particular scene. So you can tell it to load, if you had multiple scenes in your project or in your game, you can tell it to load different ones. In our case, what we're going to tell it to do is load level for the currently loaded level, which pretty much means we're just going to reload the current level. So if we go back and run that now, we get this effect, which is not quite what we want. So we can see that the level's constantly reloading, but it's not when the cactus is hitting us. The reason this is happening is because our bunny is hitting the ground, and therefore triggering our on collision 2D on collision enter 2D method, and causing the level to reset. So really all we want to tell it is that we only want to do that if we hit the cactus. And the way we do that is using, or an easy way to do that is with layers. So if we go back to the cactus, you'll see that we have a number of layers. So every game object can be set up to have or be set to be on a different layer, and then there's a bunch of functionality using what they call layer masks to be able to filter out different objects or check if an object is on a particular layer mask. So what we're going to do is we're going to create a new layer, and we're going to call it enemy, and then we're going to go to our cactus, and we're going to say that our cactus is on the enemy layer. And the reason we put it on a layer called enemy is if we add other objects into the game that are also things that the bunny can crash into, we can all just put them on the enemy layer and then have a logic that applies to all of them. So if we go back to our code, what we can now add is a condition to this piece of code, and what we want to say is if the collision dot collider, which gives us the actual collider, like the box2D collider instance that's actually doing the collision. We want to get the collider's game object, so the game object that the collider is set to. We want to get that object's layer, and we want to see if that layer is equal to this layer mask. And the layer mask we're going to use is the name to layer function, and we're going to call that enemy. Right. And if it is the enemy that we've hit, then we can reload our level. So if we switch back to the game and run that now, the level reloads, and if I successfully jump over it, I survive. Excellent stuff. So we run that again. Now I jump late, then I'm all good. Awesome. So now that we have a single cactus scrolling on, what we really need is to have more than one cactus appearing, otherwise the game will be somewhat boring. So what we're going to do is we're going to create ourselves a game object that spawns cacti for us. And the way we're going to do that is we're going to create ourselves an empty game object. And we're going to call this the cactus spawn point. And if we select that, we will find it. We can press, we can double click it, and we'll find it. Select that icon, it's sitting right over there. So we could go and position it where we want, which will be slightly off screen somewhere over there. Now, if we zoom in on that, it's kind of hard to see where it is. In fact, it's invisible until we select it. So to make things a bit easier, what we can do is we can click on that little triangle there next to the square box to change its icon, and what we'll do is we'll change it into a nice blue icon so that it's easier to see when we want to position it on the screen. Alright, so now we've got our cactus spawn point. What we're going to do is we're going to attach a script to it so that it will generate a new or spawn cactus for us. So if we go down to new script, and we're going to call this script prefab spawner, and then we can go and edit it. And it's our empty class. So what we're going to do with this script is it's going to count the current time, and at certain intervals create a new cactus for us. So what we're going to do is we need a bunch of variables. So the first one we're going to do is a private variable internal to the class spawn equal to 0, and that's going to hold our next point in time that we want to plan on spawning a cactus. We're then going to add a public transform. We're going to call that prefab to spawn, and that will hold a reference to the prefab that we want to spawn. So in this case, we will set it up through the inspector. We'll assign it the cactus prefab. And then we're using the script like this because later on we'll reuse the script to spawn some of the other things in the game. So we're going to keep the script fairly generic. We're going to add a spawn rate, which we're going to make a float. And this will be the time in seconds between spawning our prefabs, and then we're going to add a bit of a random delay so that things are spawned not exactly at the spawn rate, but a spawn rate plus some random delay. And then in our update method, we're going to say that if the time.time, which is the the current game time is greater than, in other words, past our next spawn time that we have, then we're going to want to do a spawn. And the way we use that is we use the instantiate method. And the way what you pass into the instantiate method is the prefab you wish to spawn. So we're going to do our prefab to spawn. We have to supply it the position, and in this case we're going to go transform, which is the game object that this particular script is attached to. So it's going to be our cactus spawn point game object that we created there. We're going to do the transform.position. And then we also have to supply the rotation, and in our case we don't really want it rotated, so we're going to use a quaternion, which I'm horribly misspelling here. Give me a moment. There we are. Dot identity, which is pretty much a zero valued quaternion. And then we're going to do next spawn is equal to time.time. So in other words, the current game time, and we're going to add to that the spawn rate. So good grief, the spawn rate. So in that case, it would default to the 1 second value that we have at the top there. So it'll be 1 second from the current game time, and then we want to add some randomness to it. So we're going to do the random dot range. Oops, capital R. Or rather, let's try that again. We want to do random dot range, and in a range of 0 to random delay. And my autocomplete is messing with my code. All right. So what this is going to do is going to take the current game time, add our spawn rate to it, which is by default 1 second, and then add an additional random amount of time up to random delay. All right. And I think we're good to go. Save that up. Okay. So we run that now. We will get some errors because we haven't assigned the prefab to spawn there. So currently we don't really have a cactus prefab, so we're going to take our cactus object up here. I'm going to drag it down into our prefabs folder to create a prefab, and we can remove it from our level. And then we go click on our cactus spawn point, and we see here's our prefab script that requires a prefab to spawn, and we can drag our cactus into there, and we should now be able to zoom out there. And so if we run that now, we get a cactus and another cactus, and you see they're coming through at not quite every second. And of course we run into one where things reset, and off we go. So let's just tweak some of those settings slightly for the cactus spawn point. So let's leave the spawn, say, at 1, and we'll adjust the random delay to 3 so that there's a bit more variance in there. Jump. And I think the other thing we can do, just to make things a little bit more exciting, if we click on our cactus prefab, we can adjust our speed to something maybe like 7. Let's see what that does. Alright, that makes things a little speedier. Alright, I think we're good. Now, this bit of code is not the piece of code that I have in the final game. So we'll probably come back in a later video and tweak the logic for that spawn point to make it a bit more challenging, and also for it to ramp up and get harder as the game progresses. So speed up the rate at which the cacti get generated. But for the moment, that will do us. Now, one of the things you may have noticed if we run in the game is that as the cactus get created, you'll see over here in the hierarchy new cactus objects being created. But if you watch carefully, they never seem to go away. They're there forever. An easier way to see this is if we just disable the bunny for the moment and run the game. We switch back to the scene, we can zoom out. What you can see is that we've got cacti being created, and they just keep on going forever and ever and ever, just keep piling up. And this isn't particularly good because, you know, after the game's been run for any period of time, we have a whole bunch of cacti objects consuming resources, memory, and execution cycles, CPU, not doing anything. So really what we want to do is we want to destroy them once they get out of the off screen on the left hand side there. So to do that, what we're going to do is create yet another empty game object. Create empty, and we're going to call this game object the destroyer, and we are going to also once again give it a tag, a nice red one, and so it's nice and obvious where we've put it. We're going to grab that and drag that off to the side here somewhere, and we're going to add to it from physics 2D a rigid body, and we're going to do that so things can collide into it. We're also going to then add a box collider so that it's got an area to be collided with, and what we're going to do is we're going to edit that box collider to be a nice big collider like this. So anything hit in that area. The other thing we have to do is we're going to mark our rigid body as is kinematic, because if we don't, when we run it and we go back to the scene, we can see our destroyer object dropping off the bottom of the screen there. So we're going to mark that as is kinematic. Now the problem is if we mark it as kinematic, then our on collision enter 2D doesn't get called by Unity. It's a bit of a quirk because in the 3D engine you can have an object call being kinematic but still have its on collision enter method being called. But it doesn't work with the 2D physics engine. So to work around that, what we're going to do is we're going to mark our box collider as an is trigger, which means it will be used as a trigger as opposed to a collision. So it will, instead of registering as a collision, it will register as a trigger being fired. And now we can add a new script to our destroyer object. We're going to call that script destroy on hit. I really need to find out why it's doing that and tell it to ignore that. But in our destroy on hit, we can get rid of the start and update methods. We don't need those. And we're going to add an on trigger enter 2D, and we're going to take in a collider 2D. We're going to call that other. So that's the thing we've collided with. And what we're going to then call is the destroy method, which is used to destroy objects. And we're going to say other dot game object. So what we're going to do is we're going to find from the collider called other the game object that was that we collided into, and then we're going to tell Unity to destroy that object for us, or that game object for us. So if we jump back to our code and run that now, we switch back to the scene, we can see our cacti being created and then being destroyed. As soon as they hit the box collider, you can see them, of the destroyer, you can see them being created and destroyed over there. Alright, so if we put our, re-enable our bunny and save that all up, save scene and save project, and run that now, we pretty much, at a really high speed, perhaps too high a speed, have the, yes, I think our cacti are moving a little too fast there. So we've got prefabs, cacti, and in our move left we put it back to 5, and we'll run that now. That's a bit better. It's a bit more of a sedate pace to start with. But we pretty much have a functioning end-to-end game. We have multiple cacti being appeared, we can jump over them, and if we get hit by cacti, the game resets and we can pick up where we left off. So pretty much the meat of the game is in play. Whoops, can't jump too much, and off we go. Great stuff. So that's it for this video. In the next video we'll be adding a death scene for when the bunny hits is hit by a cactus, so it doesn't just abruptly restart like that, but plays a bit of an animation. And then we'll also be tweaking the logic behind our spawning code there, just to make it a bit more interesting. So we'll probably do something where it has a slow rate of spawn and then gradually increases as the game progresses to make things harder and harder. As always, please like this video if you liked it, share it with others you think might find it interesting, and of course remember to subscribe to the channel to receive notifications when we do new videos. And thank you very much for watching. Cheers.